All right, so we're back here for part 3. So we're going to do the check your understanding part. So let's run through an example here. Calcium is a vital nutrient for healthy bones and teeth. The National Institutes of Health, NIH, recommends a calcium intake of 1,300 milligrams per day for teenagers. The NIH is concerned that teenagers are not getting enough calcium on average. Is this true? So number 1 is to state appropriate hypotheses for performing a significance test. Be sure to define the parameter of interest. All right, so we've got a couple things happening here. This is really centered around the number 1,300 milligrams. That is what the recommendation is. The concern, though, and our question, is that what teenagers are really getting? So we're concerned that teenagers are not getting enough calcium. Okay, so the parameter that we're going to use, we always want to define that. So we're going to use mu here, and that would be the true, or we could say the population mean daily calcium intake for teenagers. Now you'll notice we're not putting any numbers in here. We are just stating our parameter of interest. What is it we're talking about? We're talking about the daily calcium intake. And so what we want to know is whether we think the recommendation of 1,300, are teenagers actually getting enough of that? Okay. Now this is not a proportion. This is going to be a mean. And so the parameter is mean. We're not using a sample mean. This is the true mean. The null hypothesis is what we're calling no news, or kind of what's the status quo. In this case, it would be the recommendation is 1,300. So our null hypothesis, okay, I'll put a colon there, is that the true mean is equal to 1,300. I'll go back and I'll also say this is milligrams, our daily calcium intake. All right, so the status quo is that the mean is 1,300. Now, our concern is that teenagers are not getting enough. So the alternate hypothesis is that the mean is actually less than that. So that what teenagers are really getting, our concern is that it's less than the 1,300 that they're supposed to have. Okay, so the null hypothesis, where we're starting from, is that the true mean is 1,300. That's what the claim is. But then the concern here is that for the alternative, no, that's not the case. We actually think the true situation is that it's less than that. All right, researchers decide to perform a test using the hypotheses stated in number 1. They ask a random sample of 20 teens to record their food and drink consumption for one day. The researchers then compute the calcium intake for each student. Data analysis reveals that the sample mean is 1,198 milligrams, and the sample standard deviation is 411 milligrams. Researchers performed a significance test and obtained a p-value of 0.1404. So now we will be doing the test in the next couple days, but they have done all of this for us. Okay, so they ran the test, sample mean, sample standard deviation, the probability of us getting that based solely by chance, assuming that this 1,300 is actually the daily intake, the probability of getting those results were 0.1404. Explain what it would mean for the null hypothesis to be true in this setting. So, if H naught is true, then the mean daily calcium intake for teens is 1,300 milligrams. if the null hypothesis is true, then that means our null hypothesis is that the true mean is 1,300. So if this is true, then the mean daily calcium intake is going to be 1,300 milligrams. Now, interpreting the p-value here, the p-value is assuming that H naught is true. That's where we're starting from. Assuming that that is true, okay, that the mean is 1,300, the probability of getting a sample mean which is 1,198. Now, assuming that the null hypothesis is true, the p-value is the probability of us getting a sample value that is as extreme or more extreme than what we got. Now, in this case, the sample mean was 1,198. More extreme with that, in this case, would be lower. Because remember, we're trying to show that if the true mean is 1,300, our alternative is that the true mean is actually less than that teenagers aren't getting enough. Okay, so the probability of getting a sample mean at this level or lower, in this case, the probability of that is 0.1404. So again, we're going to ask ourselves, how unlikely is that to happen? If it's extremely unlikely, then that means that the hypothesis is probably false, and we're going to go with the alternative here. But if the probability is not that low, if it's more common, then we are not going to be able to reject this, so we are going to have to maintain that the mean is probably 1,300. All right, so here we go. What conclusion would you make at the alpha, that's our significance level, 0.05? Since the p-value of 0.1404, since that is greater than alpha equals 0.05. Okay, so we come back up here. If the p-value is greater than or equal to alpha, then our results are not significant. If our p-value is less than alpha, then we can say that that is significant. So in this case, since the p-value is greater than alpha equals 0.05, we fail to reject H naught. We do not accept the null hypothesis. What we say is we fail to reject it. There is not convincing evidence that the true mean daily calcium intake for teens is less than 1,300 milligrams. So since our p-value is too high, 0.1404 is greater than our alpha significance level of 0.05, we fail to reject H naught, which tells us there's not enough evidence, there's not convincing evidence that the alternative is true. So by failing to reject H naught, that means that, we thought that teens aren't getting enough, but we don't have enough evidence to really make that conclusion. Okay, so there's not convincing evidence that the true mean daily calcium intake for teens is less than 1,300. And that is the end of the notes.